Okay, this is AC series parallel. Let's look at this circuit. This is E total, the voltage. We have R1, R2. We have an inductor, which is already an inductive reactance, and we have a capacitor that is not in capacitive reactance. So we have to put this in capacitive reactance, so then everything in the circuit is in ohms. So what's X of C? X of C equals 1 divided by 2 pi FC. The frequency is 2K, and the capacitor value is 1 microfarad. I like to put that in the middle because that drives me a little crazy. So when you do the calculations, and this should all be under parentheses, 1 divided by 2 pi FC, you should get 79.58 ohms at an angle of -90. We add because it's a capacitor. So this is X of C. So we cross this off and we put 79.58 ohms at an angle of -90. So now everything is in ohms, so we could now evaluate our circuit and minimize it. The first thing we see is 300 in series with 500. So we note this. 300 ohms in series, so we add them, 500 at an angle of 90. And you should get, when you add these two together, 583.09 ohms at an angle of 59 point, what does that say? 04. So this is the combination of both of them added together. Okay, so now we basically just added them together. We have to redraw. Remember with AC, when you combine two components, you have to add them in a box. So we'll have 25 at 40. We haven't done anything with that. We didn't do anything with this 1K. We didn't do anything with this capacitor yet. So this is 79.58 ohms at an angle of -90. When we combined the 300 and the 500, we got 583.09 at an angle of 59.04. Okay. So now, what do we see? Well, we see this in parallel with this. So we have to do that parallel combinations. And we always note it, 79.58 ohms at an angle of -90 in parallel. That's why we see the parallel lines, 583.09 at an angle of 59.04. When we get the parallel combination, you should get 89.84 at an angle of -85.45. So that's with the parallel combination. So now we have to draw it one more time. We have 25 at 40. We have 1K, and then we have 89.84 at an angle of -85.45, right? So what type of circuit do we have now? That's right, a series circuit. So we have to treat the series circuit as if it's the only thing. So we have to get Z total by adding this and this. And when you add that, you should get 1.011K at an angle of -5.08. That's your Z total. How do we get I total? Remember, still Ohm's law, I total is E total divided by Z total. So when you do that, you should get 24.73 milliamps at an angle of 4508. So this is the current for this circuit, 24.73 milliamps. And don't forget to write your milliamps and calculate it like that at an angle of 4508. So that's the current. So now what we're going to do is multiply this by this current by this to get their voltage drops. And their voltage drops must add up to E total of 25 at 40. When you do that, you should get 24.73 volts at an angle of 4508. Here, the voltage is 2.22 volts at an angle of negative 40.37. This voltage plus this adds up to this. We know that this circuit is correct, so now we go back. We say, how did we get this? We did the parallel combination. What's constant in a parallel circuit? Voltage. So this voltage is going to go back here and here. 2.22 at an angle of negative 40.37. 2.22 at an angle of negative 40.37. Okay. E divided by Z gives you I. So this is the current. E divided by Z gives you this current. We're going to put it over here because we're running out of space. So when you do this divided by this, you get 3.81 milliamps at an angle of negative 99.41. When you take 2.22 and divide by this capacitor, you get 27.90 milliamps at an angle of 49.63. So now, so far, you have current and voltage for everything. Last but not least, you have this 300 and 500, which is this 583. This is the voltage across this. This is the current through this. We got this because we did the series combination. What's constant in a series circuit is current. So this current will go back here for these two. So we'll multiply that by 3.81 milliamps at an angle of negative 99.41. So that's the current for this and this, because they are in fact in series. Last thing we need to do is multiply this current by that, this by that. Those two voltages have to add up to where it came from, which is that 2.22. When you do that, here you get 1.91 volts at an angle of negative 9.41. When you do this times this, you get 1.43 at an angle of negative 40, what is that, negative, let me take a look, 49, what is that, 44, no, 99.41, 99.41, that's a big mess. So this voltage here is 1.43 at an angle of negative 99.41. The voltage for this is 1.91 at an angle of negative 9.41. And now you're done. You have voltage and current for everything. All right. See you in a little bit.